open this class. Okay, so we know that a string can hold a sequence of characters or a list of characters and only characters. And a vector can hold a list of different data types or objects or even our own user-defined types. So in essence, the vector's a powerful list, right? So what I talked about on the previous class about strings and vectors, that's about as complicated as this course will get as far as using those two data structures. So, I mean, you have to know how to create a string, how to query its size, how to modify a character within the string, and that's about it, right? And the vector, create a vector, add elements to the vector. We don't worry about deleting the items from the vector in this class. So we just add and we update, and that should be sufficient for the assignments that we get in this class. Okay, so examples, we're still here in module 4, but we will not use that one. We'll use this one. And we have some code that we've written before. Well, actually, I think it is this one. Let me check. Or this one. Yeah, it's this one. So module examples, module 4, value and reference, actually vectors, right? So we'll go here and okay, so how to pass a vector and string to, we'll merge them, right? I know it says vector there, but we'll create a function for each. So let's start with create a function prototype, a void type that loop string with index. And I know we did this in main, but we're gonna use them in the context of function parameters and how they affect the original variable. So string, and then we will do something silly in here, loop with index. So we can use a for loop, right? So recall that we want to use this special type definition, simply fancy name for unsigned integer, meaning only this only supports positive integers. For size ti equals 0, I less than string dot size and increment I, and then we will just say the current character at I, change it to something, whatever, and then we'll examine how this looks in memory. So with what we know about function parameters, we know that this is a value parameter. Thus, when we send in a string from another code page or code region, a copy is going to be created. So we should understand that this statement right here, string of I equals z, will be changing the copy and not the original. But we will still verify this to make sure that we are understanding. So first thing we do is, even though we do not return a value, we can create a test case just to prove that our diagrams are going to be correct. So let's go and create a test case for this. Examples. Yeah, I guess I'm getting a little too excited today. I didn't hear him. I don't know if there's something wrong with my headset. Okay, so let me go back here. Module. I should have copied everything, right? Yeah, so we copy the prototype and add the code in the CPP. And we have, I think we need this one. Okay. Okay, that looks okay. So prototype, function implementation. Okay. Yeah, if Justin said something and I couldn't hear him, I don't know if you all heard him, but that's strange. Okay, so let me check my settings here. Okay, okay. Okay, y'all can still hear me, right? Okay, yeah. I was talking to the computer mic, but I don't like to do that because if my computer fan turns on, then the recording gets weird and I have to go in there and remove the noise, and that takes a lot of time, so that's why I don't do that. Okay, thank you. So we come back to... Oh yeah, so we're just going to loop to the string, and we're purposely going to change every character in the string. And we do this to determine if the copy changes or if the original variable changes. That's why we do it, just to make sure that you understand completely how function value parameters work and how function reference parameters work. So we have modules 4 test. We have a lot of tests here so far. So test case, test function value parameter with string. Include vec.c, .h, and since string is included here, when we include vec.h here, then implicitly we're also including string. So I should be able to simply say string. We'll create a string, give it some value, and then we go ahead and call our function. It's loop, okay, and we send in str as a function parameter, and we want to make sure that str is equal to what? Parameter to C. Okay, let's look at the 4Gs. Anyone else? So again, size T is a special type definition for the data type unsigned integer. What is an unsigned integer? It's a data type that only supports positive numbers. Okay, nobody else chimed in, so let's let the test case help us, right? So we come here, classwork, not classwork, examples, module, run in terminal. And it's building. Forgot to open OneNote. So let me open it. And we are here, strings. Function value parameter. And let's see what happens. Well, it's still thinking. I guess what I'll do is, well, it's compiling. Well, it finished. What happened? Test function value parameter with string. So why did it fail? Oh yeah, I did. It's right here. So let's look at the function prototype again. We have a function parameter here, value parameter. So what happens when we use a value parameter? Let me, we created a string str equals John. John, some address, and then we call the function loop string with index, and we use string as the function value parameter argument. So what happened? Yep. Yeah, so say it chose this 32 and 33, and so it's working with a copy, right, and not a actually that's incorrect, right? So so it created a temporary copy, and these are the values that changed to Z. So the copy changed to Z. So then our test case should be checking that we validate that John, string John, stays string John, because in the function we are changing the string, but it's a copy that we're modifying. So if we run this again, then our test case will pass. Right, so yeah, it's a value parameter. So how do we know it's a value parameter? We don't have the reference, so it's not a reference. So that should have alerted you all that, oh, it's going to create a copy, and we are working with a copy within the function. So it's building. Any other questions here? Yeah, so vec.age has a value parameter, meaning any parameter that we pass into the function, a copy is created, right? So a copy of any string we pass. In this case, we pass string John, but a value parameter by definition states that when we use it in a function, then a copy is created. So we create a copy of str. So in our test case, that's what we want to validate. We want to validate, yeah, in my function here, I am purposely changing all the characters in the string that I receive to Z's, but I want to make sure that I prove that it's modifying the copy and not the original. This is the original. Once we pass it in here, it creates a copy. So we call the function finishes executing, and since it was working with a copy, then the original, this guy, should still be equal to John. So that's why, yeah, so that's what the diagram represents. Make sure that you remember that, right? Because you'll see it again and again for the rest of the semester. Okay, so yeah, it's just this piece right here. Yeah, well, you have to declare it like this, like I did. It's not a 1 like the last time, or a nail, or no? Okay. Yeah, it should work. I mean, this size T is nothing fancy. I mean, it's available to everyone. We don't have to include anything. We just have to prefix it with this. I can check it out in the lab time. Yeah. Okay, so now let's do the same thing, but with a yeah, so if you can't find test cases, then make sure that let me see. Okay, make sure that in the CMake list files, so test examples, make sure that in this examples folder you go and scroll to the bottom and open the CMake list and check that 04 module is not preceded by a pound sign. And that's how you open them up for compiling. Okay, so we'll do the same thing, but we'll use a reference, right? So we'll use a reference parameter, and then we will use the same code. So we come here, reference parameter, meaning we are now working with the original memory location. So we copy this guy here, and then what should our test case look like now to test that code with a reference parameter? Test function reference parameter with string. Okay, anyone? So this is easy, right? So we have to create a variable, and then we have to call this function, and we pass in string. And what should our assertion with the required statement state or check for? John? It's a reference parameter, and then the code's gonna do this, like change all the characters to the letter Z. Alright, so string should equal to 1, 2, 3, 4 to 4 z's now, because now we are working with the original value, and that should be the case. Why is it frowning at me? Did I forget anything here? Let me build. Okay, so let me see here. What's going on here? Oh yeah, sorry. Thank you, Tyler and Leonard. I didn't notice that. Okay, thank you. So we can run it now, and then we'll diagram it. I guess we'll diagram it while it's running, right? So now add page. So function reference parameter. Same code. We have a string str equals John, and then we call loop string with index a reference function str. It's gonna choose some address, and this one will point to here. X4, this would be like some random memory. 53. Like that, and this would be pointing to address 50, and when we call the function, that parameter is also pointing to the same address. That's the same data, and that's why we are able to modify the values, the original value. So John should be z's, right? So green we know is good. Up arrow space dash s enter. We're interested in test function reference parameter with string, and yes, str is equal to 4 z's. So any questions here? Yes, it's right here. This is the latest code, 15 through 21 that I wrote. Well, I copied it, right? Okay, so now let's continue using string in functions. But now we will create loop string with for ranged loop, and we will, this one should be easy, hopefully. And we copy the prototype, and then we can say for auto character for each character in the string variable, modify the character to some other guy. So we can go and create our test case, and hopefully so this is test case test function value parameter with string for ranged loop. So we use the same variable same value but different. We know that they're y's inside, right? So we do have to call their function. Loop string for ranged, and our require assertion should be what? Str would be equal to what? To John, yes. I was looking at the computer timestamp. Yes, to John, because it's working with a copy, right? So we're not gonna draw the diagram again. We'll just go back. So it'll be working with a copy within the function. Okay, so it's this same diagram. I won't diagram it again. And then we go ahead and run it. It's giving me a warning. Let me see. Oh, did I write the code or no? Yeah, I am. Okay, building. And notice we didn't create a function for the const reference parameter, because we know the const reference parameter, although it works with the original variable, it won't let us, in the function code, it won't even let us try to change that variable to something else. So that's why we can't create a test case for that. Okay, so test function value parameter with string for range loop. So yes, John equals John. So that's good. Okay, so now let's create another one for ranged reference. So we just simply change this to a reference, copy the function prototype, and go to the CPP file, and we execute the same code. And then we go to our test case. And I think I'll just copy all this because I don't feel like typing everything. For range, so instead of value will be reference here. And then I have to call the reference function. So then I ask you the question, what will str be equal to? Okay, so let me make sure. Am I using y? Yeah, okay, I'm using y. So 1, 2, 3, 4, y. Okay. Okay, so let's go ahead and run it. Saying I'm not using C, but I am using it, so I don't know why it's giving me that warning. It's building. And I'm going to tell you right now that will it pass or fail? From what we know about parameters, it should pass. It's a reference parameter. But it fails, right? So, I mean, it's the same code that we use for string. So So for string, we said we could use a reference and loop the index. So it must be something with the for range loop that's causing this to fail. So what is happening? Okay, so that for loop for auto C in string, this is the function code, C equals Y. So according to this, then this right here, a copy of each character in the string. That's why it fails. So we have a JOHN and at some address here, right? Like whatever. Oops, 21, 22. This is pointing here, X19 or something like that. So each time it's looping, this guy creates a copy of the first letter J, changes that character to Z, but then the loop exits, and then this address is free again. This address is available again, and then O is stored here, and then we change it to Y, and then the loop exits, and then that address is free again, and then H is modified to Y, the loop exits, and then N modified to Y, and then the loop exits, right? So this guy right here must be a value target variable, so it's creating a copy. And that's why our test case failed. So the question is, how do we fix it so that our test case can pass? So let me, yes. No. So this code right here is this code, but I didn't want to write the whole function, right? So we get the original location. Notice I didn't create any copy of the string over here in the heap. So it's working with the original location. This str is the original location, but the loop, when we say for each character in string, it creates a copy of each of the character. So then we modify the character to Y, and we do that for JOHN. So it's just the way we're looping. It's not that there's like a lot to, I mean, for characters, for the computers is nothing. Yeah. So the question is, how do we fix it? So we'll fix it. So first of all, let's fix our test case. So we know that now this one should be John, and then we say for ranged with value. I think they call the target variable, value target variable. So now we'll say, okay, so first of all, let's create the function first. So let's come over here and let's fix this stuff. So then we'll say, okay, for ranged ref. And then we go ahead and copy that to the CPP. And we can go ahead and use this code again, but we know we cannot use it. We can't use it like this. We have to modify something. So Who can tell me? What do we have to do? So if that's a value target variable, I want to make this a what? Yeah, Vince, yeah. So we want to use a reference here. So now we'll be working with the original heap location. And once we do that, then we will be modifying the original character in the string for each loop iteration. And we can go ahead and test this. By going to the test case, and I guess I don't, yeah. Let me copy this. Control C. I'm going to put forward slashes there. Okay, with reference target variable. And then we call the function for range.ref. And now this one should be, what do we say, wise? Wise, right? So 1, 2, 3, 4. And then I can get rid of this guy. Okay, so now when we look at this code right here and we have the reference to the target variable, when it loops the first time, it will not be creating a copy. Instead, it'll be pointing to the string's characters memory location. So in the first loop, it'll point here, the second loop here, the third loop here, and then the fourth loop here. And John will be modified to all wise. And we can execute this test case. And if it's still hazy for you, we're going to do it one more time. We're going to do write the same code, but for vectors, just to make sure that we understand variable, value variable, function parameters, and reference parameters. And then, like, if we need more complexity, right, this for range loop, that's another curveball to us. So. Right, so we know in the history of C++? Or yeah, like if we're working with large lists, then we don't want to copy them all over the place. And if we're using strings, even though strings aren't that large, we probably don't want to copy them either. And this becomes like more important, like if we're creating application for microcontrollers, or like a robotics application, or an application for the Mars rover, right? Like when memory is very tight, then that's when we would make sure that we use references, so that, I mean, there's like this thing, like a robot, right, has very limited memory, so we want to make sure that we use memory very efficiently. But I don't know what was created first. My guess would be they were probably created around the same time. Okay, so green is good, and now we see that our test case passed. And please remember, when you loop with a for range loop, if you want to modify the elements or the characters, then you must use ampersand right here to tell the compiler, oh, by the way, I want to work with the original memory location of the string, right? So in essence, this is by reference, but then when we pass it into the for loop, then we have to also tell it, yeah, it's a reference too. Because if we do it like this, then it becomes a value and it's a copy. and that's why I can help you, Nick, during the lab time. So okay, so you also try this right here, CMake, and then click on this icon right here, configure all projects, see if that brings it up for you. Okay, so that was for string. So we'll do the same thing for the vectors, and just to make sure that we understand value and reference parameters. Okay, so void loop vector with index, and we'll work with a vector of integers just to keep it simple. And we will loop like we did the string. We'll say for unsigned integer or size t, I equals 0, I less than the num's size, increment I, and then here we say nums of I, we'll change them to I guess -1s or all zeros, right? So we'll change them all to zeros. And then we go and write the test case. Let me make sure I have it in the header. I didn't, right? So put the prototype here. Okay, so now my code should work. So we're doing the same thing, right? So this function is equivalent to this function. So then we should know how to write the test case. So we go test case, test function value parameter for vector. So how do you all think Python passes the function parameters? By value or by reference? Yeah, it's by value in Python. Okay, so vector nums, and we 1, 5, 10, 3. We'll work with 3 so that our diagram doesn't get too crazy. And then we say loop vector with index, pass it here. Okay, so this is there's different ways that you can compare vectors and test them, but I always like to be explicit, right? So like here, like this is what I expect, but well, at least that's what I started with. So we require that nums equal to expected vector. But is this the case? Like we expect it to be the same when we use the vector in a value? Anyone else? Are they going to be the same? Yeah, so nums should look like 1, 4, 10 because we pass it as a value, so it'll be a copy. Let's run the test case, and while it's running, I'll go ahead and start the diagram. So we have nums, vector nums. Yeah, I'll help you during the lab, Nick. So nums. I forgot the values. What were they? 1, 4, and 10. Okay. oops, hit my mouse. 1, 4, 10, and then we say loop vector with index, and then we use nums as the function value parameter. So we got some values here, 1, 4, 10 at some address. So we know that this is going to be x11, this will be like some number. This is a stack, and the heap and we expect a value parameter to get a copy. So somewhere over here in another region of memory, we'll get some other addresses. 5, 6, okay, so we have 1, 4, and 10. This points there, and this points here, right? So this is the copy. So that's why we expect the values to be the same. We didn't modify this vector, we modified a copy of the vector. So let's see, right? So green is good, so the vector stays the same because we modified the copy of the vector and not the original vector. So that's why the test case holds. Questions? Okay, no questions. So we come back and let's now create a reference for vector, right? So nums vector loop vector, so loop vector with index ref, and then the parameter is a vector type like this, right? Otherwise we'll get a compilation error. And let's go ahead and write the code. So that was by val, so we go here, reference, and then we use the same code that we did here. We simply say we want to iterate the vector and change all the values to 0. So since this is a reference, then we are going to be working with the original vector, and we expect the vector to stay the same or to change. Let me copy the test case, paste it, change value to reference underscore ref, and then what should this be? The expected vector. So let's look at the code. In the code we're changing all the elements to 0, and this is a reference, so what should the expected vector be? All zeros, right? Because now we are going to change the original variable. So that's what we expect. And we can get it running, and while it runs, then I'll make sure that we understand completely, and I'll go and diagram the vector of function reference parameter. Okay, so we created a vector of int nums 1, 4, 10, They're gonna get some addresses. This one's gonna point here, and this one's gonna have address, and this is some address. Again, this is a stack. This is a heap. And when this statement executes, that's what happens. And then we have a function call, loop vector with index ref num, or nums, right? This one will get an address here. Control Z. Let me see here. So I had here. So it's working with the original location of nums. So the test case should pass. And green is good. We know that by now. So up arrow space dash S enter. And the values did change from 1, 4, 10 to all zeros, because we're working with the original vector that exists in the test case here, and that's why this passes. Questions? Positive numbers only. Yes. Oh, okay. Okay, so now let's loop vector for range, right? So let's do this one, but modify it to a vector. Vector, so nums. Vector of int, and we have to change this to from string to vector, and that's a value parameter. Okay, so if it's a value parameter, we should know that we're going to be working with a copy, so that test case should be easy for this one. So right here, remove the semicolon, open close parentheses, and we use a for range loop here, so we can say for auto number in nums, so for each n in nums, n equals 0. So we're working with a copy, and let's go ahead and write the test case. We'll copy this. So test function reference parameter, no, value parameter for ranged, and the name of the function is for ranged. Okay. Not W, okay. Okay, loop vector for ranged. So is this all zeros or some other values? The expected vector. Keyword is right here, value. 1, 4, 10, right? Because it will be working with a copy. So we can go ahead and execute this test case with confidence, and it should pass. And we can go look at this diagram, right? So So it'll be working with a copy, but the way we're looping, it'll be creating a copy of each character here on the stack, right? But I'm not going to test you on that. Like, I just want to make sure that you all understand at least to this level. Okay, so it's still so I'm hoping that all the examples from the previous class and this class like give you plenty of practice with value and reference parameters, and then that they don't trip you up in the near future. So green is good, up arrow space -s enter. So that's good. So it was a copy and our test case passes. And then we go into the one that tripped us up initially, which was looping a reference vector with a for range loop, but the for range loop kind of tricked us, right? Because the for range loop creates a copy of each character. So vector, a vector of integer, and copy, go to the CPP, open close curly brace, and then we can copy this, put it in here. All right, just to make sure that we remember. And then we can go ahead and create our test case. So I will copy this test case and then for ranged I change this to reference. So reference parameter in a for range loop, and what's the name of the function that I need to call for? Ref. Okay, underscore ref. Okay, so we create a vector 1, 4, 10. We have a reference, but we know by now that this guy tricks us. The for range loop tricks us. So although nums, we are working with the original location, when we bring it in here, then each character is a copy of the original. So then that's why this is the same or different, the expected vector. Different? The same, right? Because although this is a reference, meaning it'll point to the original location, when we have the loop and it's looping, it's going to create a copy of 1, 4, 10 one at a time on the stack. So we'll be modifying a copy of the original. So although we have direct access to this one, because of the way we're looping, then that's what becomes a copy of each character. So we have to make sure that if you don't want to mess around with this stuff ever, then just stick to subscripts. But I want to make sure that I bring this up, because if you're working in a C++ shop and you see this and you're there spending hours and hours like, I mean, it's a reference, and that guy, he told me that reference, or I'm working with original, but this code is not working, right? So that's why I bring it up, just to make sure that if you ever see it again, that should be like, oh, I'm using a copy here. So then the answer is it should stay the same. So we'll go ahead and run it. And those warnings are bothering me. I have to look into them. So any questions on why this one would stay the same again? I mean, I know it's by reference. Oops, where's the code? like we see here, like, sir, you said by reference we work with the original. Yes, but this is what changes. When we loop, then it's creating a copy of each character. So that's why our test case should expect the elements in the vector to be the same. Right, so green is good. Up arrow space dash S enter. 1 4 10. Okay, and we're almost done here. What, 9 minutes? Yeah, we should be able to finish. So this one is the last one, right? So this one. So this changed to nums. We changed the string to vector of integers and vector of integers, and then we changed. Yes. Yeah. Okay, so then we copy this prototype. We come here, paste it in here, open close, curly brace, and then we use the same code almost with one change, right? So if you all recall the change, we have to change something in here to work with the original. So you can look at the same function, right? So the reference, right? So we want to make sure that we work with a reference, and that way now we are working with the original character address and or element address, and then we can go and create our test case. So before we do that, now we'll be working with the original location. Because of the way we're using the for range, we said, hey, make this a reference to, because I want to work with this addresses. I don't want you to create an address or a copy of the elements as you're looping over here. Okay, that's why we're doing that. So we come here and for ranged ref, and this will be for range ref. Okay, for range ref. So so what would the expected vector be now if we're working with the original? Right, 0 0 0, right? Because now we'll be able to change each element excuse me, in the list or the vector, right? So let's give it a spin here. Yeah, make sure, I mean, if it's still hazy, like make sure like a value variable is a copy, meaning in the function I work with a copy of the variable that's passed in. And if it's a reference, most of the time you work with the original, with the exception being the for ranged. Depends on how you structure the for range. If you structure it like this, then you'll be working with a copy. If you structure it with a reference here, then you'll be working with each element in the list, right? So please make sure that you make notes or somehow remember that. So green is good, up arrow, space, dashes, enter. And that's it. Like we've covered value and reference parameters. Like we've really like gone in there and created a lot of examples to make sure that you all understand how they work. Because C++, that's how it works, right? So once we have the fundamentals here and we know like values a copy, references original location, then the next question is, and I've stated it before, but I'll say it again, when do we use which ones? So if you're working with numbers, like with integer, double, char, simple data types, then you can create a you can create a copy of it. You can use it as value because the memory hit is not going to be that big, especially on computers nowadays. If you're working with strings, then go toward references, and definitely if you're working with vectors, then you want to pass vectors by reference. Just remember, if you want to get protection from accidental code changes, and we'll cover this more next week when we get into classes. Don't forget about this guy. This guy's your friend, the const, because yes, you'll give them access to the original memory location, but you're protecting the data from being modified. So, any questions? Yeah.